Hi, welcome to an Arduino tutorial from Robojax. In this video I'm going to show you how you can control a relay using Arduino with potentiometer. You can set the time, and also you set the time to turn on and off an AC or DC load like this. For example, for longer time I can cancel it at any time. If I rotate this, it goes to 11 seconds. This is a schematic that I've drawn in first thing, and this is 100 kilo ohm. This should be 10 times smaller, 10 kilo ohm. This is the time that you can set minimum number of seconds, maximum, and that's minimum, so 0 between 2 and 20. You can get the code for this by clicking on the link in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. In industrial and real-world applications, you need to control a relay with a certain time. The time that you set, either we need to have some kind of keypad to enter or potentiometer. One of the easy way to set the time is the potentiometer. As you can see, I can just rotate it. The limit for this one is set in Arduino. The minimum is 2, and if I rotate this, the maximum is at the moment set to 20. I can set to 2000 or 20,000, whatever you want. Using this potentiometer, because setting is very easy, it doesn't need multiple buttons, we just rotate it, and also quick. For the keypad to enter the, let's say 235, but if you're using potentiometer, you set in Arduino between 0 to 1000, and you can quickly go to any value. And here is an example. At the moment it's at 217, 500, and I can set it at the maximum of 2000 seconds, which I've set now. You can set any number that you want. It has multiple important features. One is that you can set the relay at any time by pressing this button, and the time is, if I reboot this, that it shows the version, also low trigger. That helps, so you can understand how you set it up. The important feature of this one is, for example, the potentiometer is now set to 9 seconds. I can press this start, and the countdown comes. At any moment you can cancel it. That's very important. And also, let's set it back. Once the time is set, this potentiometer does not have any effect. Let's say if I put it now at the maximum, even there is 0, and you can see that the relay goes off. Once you set it, this potentiometer has no effect. This button, because it's important, let's say I press it and 9 seconds. If you press it again it will set to 9 seconds. So this is a good feature. In many cases people will need it. And then using of these 4 wires with this LCD1602-I2C module makes it very easy and tidy with just 4 wires, and you can run it. If you want to know how this works properly before running this display, I will suggest that you run the code that I have only for this portion without the display. Make sure that it works perfectly before you come to this. And also for the display, many people have issues and the text will not be displayed. I have another video explaining how to use this one with the code, so make sure without relay, without potentiometer, just run this and make sure your Arduino can display a text. When that is done, then come here back and continue. Keep in mind that this relay timer will work even if you don't have the display. I know this is 2 seconds, and on the right side it's 200, so 100 should be somewhere at the middle, which is correct, and 50 should be somewhere in between, so that's also approximate. Let's see now what components we need. The first one, we need this LCD1602 with this module, that I2C, which has only 4 wires. That's the first thing. Then you need a relay. It could be relay module, or you use this module which doesn't have the light. It has negative S, means signal, and then VCC. Or you can use this relay. I have a video how to drive this. Doesn't matter which one you use, so you use a relay. Then you need a potentiometer. You need a variable resistor. Incorrectly people call it potentiometer. Potentiometer is the one that you rotate it with a screwdriver. When this has a knob this is a variable resistor, so you need one of this. Anything above 1 kilo ohm or 10 kilo ohm will work fine. The higher this value, up to 500 kilo ohm, will work perfectly for this purpose. And then you need 2 push buttons and a breadboard to connect these push buttons and wire, doesn't matter which size of breadboard. And also you need an Arduino. Any version of Arduino will work fine with some jumper wire that you need, or DuPont as they call it. Let me explain the wiring. And here is how you connect your load. This is the load, and it needs 2 wires to be connected to power. This doesn't matter if it's AC or DC, so the 2 wires are coming to the load and the circuit completes like that. Now to control it with the relay, we just cut here or do something like this. The power goes to relay. Relay needs 2 wires. When it switches it connects this wire back here and the load will turn on. So these 2 extra wires will be created. If you just cut here, it will be 2 wires. This is an AC desktop bulb, and this is a power plug that I connected to the wall, and 120 volts, which will turn on and off. Now at this point, I've cut one of these 2 wires at this point and twisted it and soldered it. Can be connected to relay. Job of relay is to connect this, and the AC bulb is on, or AC load, whatever fan you have, and disconnect it to turn it off. So I will be connecting these 2 to the relay. The first thing for relay, the 2 wires that I just showed you, 2 of them will be connected into the relay on this side. And here for the relay, the 3 pin, the first one is VCC, connected here to 5 volts. The other pin is ground. This brown is connected to the ground, and then the last one is orange, connected to pin 8. When you're using a relay, pay attention to the current rating of a relay. For example, this is a very tiny relay, and the current rating is 2 ampere for 30 volts, 0.5 ampere for 100 volts, and 0.6 ampere for 125 volts. This is the amount of current that it can handle, and this can handle 10 ampere at 28 volts and 10 ampere at all voltages, 120 and 250 and 30 volts. So to understand how much this can handle, in North America the voltage is 120 volts times 10 ampere is 1200 watt, or 1.2 kilowatt. If you're in Asia and Europe, the voltage is, let's say, 220 or 240 volts. For 220 times 10 is 2200 watt, or 2.2 kilowatt. This relay can handle. This variable resistor, or sometimes people call it potentiometer, it has 3 wires, and is a maximum when you rotate it to the right. So make sure that you connect this to 5 volts. This is connected to 5 volts. I was running out of 5 volts, so this yellow is 5 volts, and I've connected it to this module, and then this black wire is connected to 5 volts here, and then this side is connected to the ground of Arduino in here, and the middle pin, which is the variable resistance value, which reads the voltage, is connected from here to our analog 0. Let me remove this now. And for the LCD, we have on this side, we have 4 wires. From the left it says ground and VCC. Ground is this brown one. I've connected this blue wire from this ground to this brown, which is ground, connected in here. And then the VCC is connected to 5 volts at this point, which goes from this yellow to 5 volts. And the 2 last pin, signal clock and signal data. The clock is the blue, it's connected to A5, and the green is the data. Data is connected to A4. This is an Arduino Uno. Here, if you are using Arduino Uno and Ethernet, A4 is SDA and A5 is SCL. Arduino Mega, SDA is 20 and SCL is 21. Leonardo are these, and also Duo. So these are the pins. Make sure to follow this one for your board. Now I will remove this. There's one switch with 2 pins. This side is connected from this wire to the ground. So this is ground, and also the yellow is another ground for this one. The other pin of this switch is connected from here. It's connected to pin 3 on this side, and this side of this switch is connected to pin 2. And this is a schematic that I've drawn in FruitSync, and also I've made some modification in Photoshop. The potentiometer, 2 of the wires will be connected here. This is a relay. This is a power source. It could be battery or AC depending on the load. This is just a bulb. It can be a fan or another DC or motor, whatever you want. This schematic will be provided with the code in the same page. Let me now explain the code. From this point, the wire.h is part of Arduino. You don't have to worry about it. You don't have to include anything, but this is a library that I will provide the link. You have to download and install this library. And this one is the address, the I2C address. It says 16 character by 2 line, the type of display that I'm using. And so this is for the display. We are defining pin 8 for the relay, where your relay will be connected. Pin A is the center wire of your potentiometer, which is being read. And then reset pin is pin 3 and start pin is pin 2. These 2 pins are the interrupt pin of Arduino. I will provide you the link for Arduino.cc website. If you're using Arduino Uno, Nano, Mini, and the other one, the pin 2 and 3 can work for interrupt. Other pins will not work and you cannot change it. If you are using these other versions, like for Mega, these are the interrupt pin and so forth. Then we have a relay type. My relay is low trigger, put capital L. If it's high trigger, put capital H inside the single quotation. This is the time that you can set minimum number of seconds, maximum, and that's minimum. So 0 between 2 and 20. So 2 is the minimum, 20 is the maximum. And do not change these. These are the variable that is used internally with Arduino. And then inside the setup, we set relay pin as an output. Relay pin have been defined here. This is as if we type 8 and then reset pin, start pin. This is one of them, is pin 2 and 3. And we use input pull-up. I've created another video explaining what is a pull-up. It just eliminates using of extra resistor and wiring. It's always high. When you press a button, it goes low. So after that, we use this attach interrupt, and we say digital pin interrupt, and reset pin will be attached. And then this is a reset. We set it as when this interrupt happen, the reset button is pressed, we set it to low. And this is a function which I'm going to explain later. This is for LCD initialization. We set LCD begin, and then we set the backlight, and we set serial monitor at 9600 baud. If I click here, this 9600 at the bottom must match that number. Because of the type of relay, either high trigger or low trigger, at the beginning we want the relay to be off. A low trigger, we will write digital write relay pin high, so this will turn off the relay. Also, these will print the text on the LCD. These will print the text on the serial monitor, telling us what type of relay we are using at the beginning of boot. And if it's not low, we will do this one, the same exact thing, except relay is high. Now relay will be low to turn off, and all these texts. And then we wait for 3000 milliseconds or 3 seconds so the user can read this text. If you want to go quick from this, just make this 0 or remove this line or whatever time you want. After that, we clear the screen, removing all this from the screen by typing lcd.clear. The loop, we go to we use analog read, pot pen, which is analog 0. Whatever value we read, we divide it by 10. This increases the sensitivity. Usually the value is between 0 and 1023, and because it's fluctuating constantly, we have to divide it by 10. So we will discard one digit from the right side. It will become 1023, become 102. So the value that we read divided by 10 will be stored in pot val, potentiometer value. And here we use the map. we say potentiometer value should be mapped, which is from 0 to 102, because we have converted it. We say map it 0 to this minimum time, and then 102 to this maximum that we set at the top of this screen. And then the result of this mapping calculation will be stored as an integer. We call it duration calc, or calculated. And here we check digital read, start pen. If it's pressed, it will be low. We put double equal sign low. If it is low or the button is pressed, then we say store this calculation inside this variable called duration, and this will hold it, which have been defined at the top. And then we remember current time. We say mils divided by 1000. It remembers current time. This is the time that from the boot it starts with milliseconds. As soon as you start the Arduino, you have a timer just runs, and it will be within few seconds. It will be, if it's 1 second, it will be 1000, and 2 seconds it will be 2000 or something like that. So we divided by 1000 to make it second and store it, and we call it remember time or rem time. And because the button is pressed, we also set the relay state as 1 or relay is on, and then also we send a command to control relay. This is a function that I will explain next. And then we check in here, then we say millis divided by 1000, so find the current second, because it will be higher than the remember time. If this result is bigger than duration that was set here, then we have to turn off the relay because the time has expired. So we send relay state equals 0, and then control relay command will run. This is printing the text on the serial monitor. After this portion of the code is only to display the information on the screen. Let me explain it. If the relay is on, this will be executed. If the relay is off, this will be executed. Let me explain this, because relay is now off. We say LCD display. This is a function that takes these arguments. The first one is the row. So this is the row, first row 0, that is row 1. So this 0 means row 0, and set time, display this text. After that, show the calculation, the duration of calculation of this potentiometer. Now if I turn this, you will see that I'm rotating the potentiometer, and it goes to 20, 15. All these values will be displayed there. And the next line we say go to row 1, and then display relay off. Now if let me set this for longer period. If I press the relay is now on. Now this is at the row 0, it says the duration, and also it shows the remaining. This text is for the remaining, and it is countdown, and get time is getting the time, and it's showing it for us here in real time. That's a very good practice to tell you if the time is up or not. So let me show you get time. This is a get time function. Get time gets the duration, subtracts millisecond divided by 1000 minus remaining. So this will give you the time that is displayed there. And now for a LCD, this is the row that we pass. That's the text, value of the text, because in each line we will have a title, a value, and S at the end. So this is the S at the end, this is the title, and this is the value 20. We have another function called clear row, and the job of this one is to clear a row, and it sets empty on all values when the loop runs. The reason for using a separate clear row function is that we want this not to change, but we want only the second row to be cleared. Otherwise, there is a function called clear, and it will clear the whole screen. I have written this so it can clear any row that you want. So you will call it like this, clear row and then row number. When you write something, we just clear that row. If you put here 2, 1 will be cleared, or if you put 0, 0 will be cleared. Demonstrated, as you can see, also serial monitor is showing the data. It shows that relay is off, but the most important part is for us this one. Now the time is set for 5 seconds here. If I rotate this, it goes to 11 seconds, and if I press this, the light is on. This 11 shows the countdown, and it goes until it reaches 0, and it turns the AC bulb or DC load, whatever you have, it will show the relay off. Now if I set this, let's say for 9 seconds, turn this on, and there is a cancel button. At any moment you can cancel it. When the relay is on for 9 seconds, after that, even if you change this, the potentiometer, it will not have effect, and the relay will go off. And also another feature is that when it's at 8 seconds, let's say at 7, I turned it on. And after that, if you press this again, it will reset the time, because pressing the button should not happen, so it will reset the time. Let's discuss the issues that you will face with this timer. Let's say you set the maximum time to be 200, 500 or higher value, let's say more than 100 seconds, you will face some challenges. So here I have a potentiometer, and with a 200 I'm almost at the middle, as you can see here. So I'm getting around 100, and then if I rotate it to the maximum to the right, I'm getting 200. But the problem is that if you want let's say 155, this will be very hard with this, because as the value increases, the maximum value increases, it will be very hard. Let's try 155. So 49.51. So it was just by chance that I was able to do it. Otherwise, it will be very hard. Maximum time increases, it will become very hard. But what you do is, we have to put another potentiometer in parallel with this. So we will call this fine tune, and this will be coarse. And here is how you connect your potentiometer. For example, this is 100 kilo ohm. This should be 10 times smaller, 10 kilo ohm. And this side is connected to the ground. This was connected to the 5 volts. Now we have added the fine control, so connected on the left side, and the middle one will be to the 5 volts, sorry. And this is still connected to analog 0. With this you control the minimum and maximum. Make sure to put this at the middle, and then when you set whatever value you have from the middle, you can go left and right and have finer control. When you are adjusting it, so this is the coarse, this is the fine. When you're adjusting it, put this at the middle and then adjust your time here. Now this is 108, it's fluctuating, but with this one now you can control with very little. You see the all move, we just moved it a little one. And if I go left, I can select almost 102 and 4 if I cannot select the 3 at least. But with this one it will jump very quick. The issue that you will face is as the maximum time is increased, you will not be able to select, let's say 2 seconds. The minimum is 2. It will be very hard. Now I'm putting this. Now I'm at the minimum. It shows 5 seconds. Even though I have set this for 2 seconds, I will not be able to do it. The reason for that is that this is now at the maximum. So I have to put this somewhere at the minimum, rotate this and bring it back, and you will see now 2 seconds. So keep that in mind. This is the issue. For large range, you will face some problems, so you have to play with these. Thank you for watching. This was Robojax Relay Timer version 1.1, which utilizes a display. If you like this video and if you're using it for your application, please thumb up the video, and also please write comment. I appreciate it. If you have comment or question, I'll try to answer and reply. And subscribe if you haven't done so far.